change the die. Well, it usually took a whole afternoon, 4 or 5 hours to change the die, and that was fast at that time. So then he gave an order to Shingo to see if he could fulfill it. He said, I want you to give me where we can have what he called, be able to change our dies in 10 minutes. 4 hours. And Shingo thought Ono was crazy. But Shingo's the guy that knew how to do it. In the meantime, he'd actually been collecting information from working on all these different jobs over a number of years. He describes it beautifully in his book. He's got all this different information. And all of a sudden, after Ono told him, he said, you know, maybe we can do it. He's putting it all together. Ono didn't know whether it could be done. He said he just gave it to Shingo. He didn't know what else to say. Gave him an impossible task. Guess what? Ono did it. Nobody had ever done that before. Then after he thought it over again, he started about thinking other stuff. He was able to do it down to 3 minutes and eventually got it down to 1 minute exchange of die. Well, then you have no longer an economic life quantity. But you can just change this stuff back and forth. And you have one production line, just run different kinds of models. And he's drawn from all these different kinds of things. He's explaining all he's drawn from. Boy, is that guy ever building snowmobiles? So is Ono. And they're drawn from other guys. And one thing interesting about Shingo all the time, when he hears somebody say something, he listens very carefully. He always talks about, I gotta listen. He's saying something different. I haven't heard this before. He said, this one can think it's wrong, but it might not be wrong. It's only wrong because I haven't thought about it before. So you always have to be prepared. You notice how some people say, that's wrong. Shouldn't say that. Okay, I'm listening. Be in receive mode. In fact, we had a guy when he was up in the Pentagon, and we called him Dr. No. Boy, great logic. Fantastic logic. When we had the initial meeting, said a lot of this stuff, he'd come in here and destroy the whole thing. He always said, this can't. I finally said, no way, you're out. Never come in here again until we're ready for you. So remember what I said? Observations, analysis, synthesis, hypothesis, and test. The test was to test it against him. After we had it all figured out, he said, boy, this guy really knows how to chop stuff. We're going to let him look at it at the end, not in the beginning. Never get him in there in the beginning. Very sharp, very qualified. So I brought him in the beginning. He had a skill. I said, Howard, you're not coming in here until we're ready for you. I said, because if we bring you in here, we got a disaster. So I bring him in, and now let's chop it. He'd come in, so fine, out the door, wouldn't let him in again, rework the thing, ready, back in, out, back in until we got it right. So he had a role to fill, and he did it very well, but not in the beginning. Go ahead. Well, one of the things is that, as I told you before, if I can go through my development loop faster than in fact, I got some articles here I'm going to leave here, which is well, no, they're not discussed. Yeah, it is discussed in here. No, not the one I got. Damn, it's not in there. I thought it was. Not in that one. But in any case, if you can go through and set up a faster tempo rhythm than your adversary, you're in effect doing that to them. And that's what Ono and Shingo did, what they were able to do. See, in the United States, we're better now. So when I'm talking about this, I'm talking about prior to 1988 or 89. Now we're getting better at General Motors. General Motors still got some problems, but for they're turning things over from, in order to make a design, it used to take us about at least 5 years. In other words, we had an idea till finally got the design, try to shove it out the door. You understand what I'm saying? Automobiles I'm talking about. What Ono and Shingo figured out how to do, I mean, as a result of their activities, it sort of fell out. I mean, they didn't start this way. It's sort of a fallout. They were able to start with a new idea on a design, come up with a new car, and do it in about 3 years or 2.5 years, about half the time. Well, think about that. If you're only doing half the time, instead of having those people working all a long period of time, it costs a lot less, too. Plus, you get ahead of the marketplace. In other words, you capture the market before the other guy does. Plus, then you got it only going down to very few production lines instead of lots, so you have less expense there. So you see how you get. See what happened? We're shipping materials to Japan, raw material. They make automobiles and ship the car back, and they can still do it cheaper than we can. Well, not so much now because we got a currency problem, but before that. Well, that means, you know, you got a very inefficient process if somebody can get away with that. Let me give you an example. Since you raised that point, a good example. It's in a book called Machine That Changed the World. Anybody read the book? It's called The Machine. It was written by the MIT team up there at MIT that looks into automobile production, those kind of things. And there's one interesting, well, there's more than one interesting, this particular chart drew my attention. In which what they tried to do, they want to compare two models, Japanese model versus General Motors model, and particularly Toyota they were comparing. Now they couldn't get it exactly, cars aren't exactly, but try to get them as exactly as they could. And over a month's production, or a couple months' production, number of cars put out, and then figure out the number of man hours that went into that car, or the labor that went into it. And at the end of it then, figure out how many man-hours per automobile on the average over a certain period. And try to do it legitimate so you don't fix it where Japanese are high one month, the other one's low. In other words, on a apples versus apples basis. Well, having done that, what they found out, the average man-hours for the Japanese per automobile, pump out a car, the model they were talking about, roughly a little over 17 hours, man-hours, pump out a car. For General Motors at that time, it's the plant they looked at, typical plant, over 30 hours, I think as I recall is 32 hours. And none of that, the Japanese quality was better. But, you know, you can't win when you can't beat somebody if that's the way the game's being played. You can't compete. And so what you have to learn how to do is, in the end, an organization by itself doesn't come up with the idea per se. There's people working together, and then in the end, you know, sometimes you have to get off in isolation and draw from somebody else, figure it out, then go back in. You just can't be there in the hubbub all the time, because otherwise you'd be like this. But in the end, you're still drawing from it. See, I learned from a lot of people. Remember what Newton said before he died? Anybody remember what he said before he died? Very famous statement. I don't know that I quoted it exactly, but I can at least paraphrase. He said, if I was able to see farther than anyone else, it's because I stood on the shoulders of giants before he died. In other words, he drew from Kepler, he drew from Galileo, he drew from Descartes, he drew from, in other words, he's taking those bits and pieces and did it. I understand that.
Because, like, taking toilet paper preparation is a way to stabilize the weight, or a botanist takes plant behavior and figures out its underlying. In trying to look at new ideas, you can't sample the entire universe. How do you make that initial decision? But what does the end of the day in your analysis? How do you make that initial first pass of what next?
It's an excellent question. I'm not sure I got a good answer, but I'll try to answer it. It's sort of an intuitive process. What I learned a long time ago is I like to look at different things. I found out somehow, I don't know when it's going to be valuable later on, is what I've learned over a long period of time. And for some reason, I was able to see into that analytical synthetic process. So you just sort of have to look at different things, not knowing whether you're going to use it. Like when I first read that, when I read some of this stuff on, when I took Heisenberg, for example, when I took physics at Georgia Tech there, I instinctively knew that Heisenberg principle had more bearing than what they said it had. And I read it, I said, okay, I understand what they're saying. I understand how they even derive the goddamn thing. But, you know, this just isn't atomic physics or subatomic physics. It must have bearing elsewhere. I mean, I didn't know, but it always in my mind. In fact, I just a few weeks ago at my physics book, I had stars all over that page, VIP, which means very important. And I didn't have it in another page. This is very important. And the reason why I remember when I went back, because this was back in 1960. The reason why I remember that, because when I took that, I was very struck by that. You have to be sort of struck by certain things because of your experience and be open.
Sure.
Yeah. But don't, I think the key thing to do that is don't try to assume that something is wrong because it doesn't fit into your orientation and say, well, that's wrong. I don't do that. Initially, I look at it and say, I wonder what he's saying here. Am I thinking about that? I always deliberately try to caution myself. I want to see, what I always try to do, and here's a key point that I try to do. This is a key point. When I'm reading something new and different, I try insofar as possible as I can, is to try, and you can't do it exactly, can I see it through his eyes, not mine? In other words, I want to adopt his point of view, suck up his point of view, so I don't let my own orientation drown out what he's trying to tell me. See? And you have to do that in the beginning. Now, and it took me, you know, when I was younger, I didn't do that. I think when I became a fighter pilot, that's when I learned how to do it. My experiences at Nellis had a very deep impact upon me. I know that. Other people know that. For some reason, because it was 19th century, I call it, see, I had a degree in economics. I said, God, this is great. This is like 19th century capitalism in the sky. You know, everybody's a freebooter, a buccaneer. This is fantastic. We can do whatever the hell we goddamn please. Those generals don't know what the hell we're doing.